Hello, everyone. This morning, I want you to join me to this journey through past, present, and future radioastronomy activities in Spain. Together, we are going through the humble beginning of the Spanish radioastronomy, the hectic present, and the promising future. The beginning, as you know, the radio waves from the universe, from our galaxy, from the center of the galaxy, were discovered by Jansky in the 30s. But it's not till the 70s that we started the radioastronomy activities in Spain. A bit late, but better late than never. And this is thanks to the NASA's Deep Space Network facilities that were installed in Spain. NASA, in the late 60s, started building antennas close to Madrid, 3 complexes in Cebreros, in Robledo de Chabela, and Fresnedillas, because they thought that the antennas could interfere between each other, so they decided to put it in different sites. Later, they joined all the antennas at in the same place. It was Dr. Renzetti, the major force behind the development of the Deep Space Network for NASA, but also he was a science advocate to use these antennas not only for spacecraft tracking, but also for science. So he pushed for the development of what we call the host country radioastronomy in Spain using the NASA stations. So he sent Dr. Esselman to a meeting in Madrid in '71. I was 1 year old at that moment. And Dr. Esselman had a meeting with Spanish representatives from INTA, from Institute Torres Quevedo, Complutense University, the Telecommunications School in Madrid, and from Barcelona University. And this meeting was hosted by the director at that time of the Cebreros station, that was Mr. Urech, that he became the director of all the NASA sites afterwards. So from this meeting, it really started this host country Spanish program. So in the intergovernmental agreements between the United States and Spain, it was recognized the importance of these antennas for scientific research. So they wanted to dedicate, NASA wanted to dedicate some part of the time, up to 5% of the total time in each antenna, for independent Spanish research. And this way, it started the host country program. And it was led from Barcelona University. So Rius and Estaleya, Tony Rius and Estaleya, were the first ones to perform a radioastronomy observation base located in Spain, using this Cebreros antenna, 26-meter radio telescope. And they've observed this occultation of a radio source by the moon. And with this, it really started these activities in Spain that they weren't doing them before. So they published several papers of these capabilities of these DSN antennas, developed backends, for instance, to detect pulsars, and the array tool that I've used, that is a software package to be able to do pointing and do single disk observations with the NASA antennas. And all this started the radioastronomy in the Barcelona University. And here you can see all these colleagues that are very well-known names in radioastronomy today. So they were doing lunar occultation of radio sources, interplanetary oscillation studies, VLBI observations, radiometric observations of hypercore radio stars, and emission of X-ray binaries. This continued, of course, it developed around Spain, and it continued with contribution from the Zaragoza University, and very important, from the Andalusian Astrophysical Institute in Granada. So there, Torrelles and Marcaide did the VLBI observations of VLAC objects, high precision relative astrometry. They did the first observations using that technique, studies of supernova remnants and gravitational lenses, etc. In parallel, my institute now, that is the National Geographic Institute, decided to develop radio astronomy in Spain further. So they decided to build the first Spanish radio telescope. That was a 14-meter antenna, 4 millimeter wavelengths, up to 3 millimeter. So the Yebes Observatory, where I work now, was created on the 74, in year 74, and this antenna was built in US, but it had a worm receiver at 90 gigahertz, 3 millimeter, that was developed at the Telecommunications School in Madrid. And the first observations were performed with the moon on year 79. So this was almost a miracle, because this worm receiver had 7,000 Kelvin system temperature, and also the efficiency of this antenna was 10–12%, no more. So it was really difficult for them to make it work. Later they realized that the structure of the antenna was not stiff enough for these frequencies, and they went down to 45 gigahertz and started a very successful program on SIO masers, a study on evolution of AGB stars, and the first detection in VLBI in an interferometric baselines with Effelsberg and Onsala of SIO masers. So these two groups, of course, build their capacity abroad. Okay, we have to thank to all these institutes abroad to have teach us about observational techniques and how to do science in radio astronomy. So we owe to NASA, JPL, NRAO, MIT, the Max Planck. And from the NASA group, all this know-how was spread throughout Spain. The other group also was improving their know-how, but very importantly, not only they've learned about observational techniques and how to do research in radio astronomy, but also how to develop instrumentation for astronomy from the Paris Observatory, Max Planck, Charles Mer, NRAO, MIT. Okay? So from that moment, in Spain, we acquired the capability to be able to develop our own instrumentation. Okay, so the at present. This is the map of the classification of these unique scientific and technical infrastructures that we have in Spain. It's a classification that is given by the Science Ministry, but thanks to that, you can opt to European funds to keep your facility, your instrumentation up to date. 7 of these facilities are dedicated to astronomy and astrophysics, and 2 are fully radio observatories, the Yebes Observatory and IRAM in 30-meter antenna in Pico Veleta in Granada, and there's a radio astronomy instrument here in Tenerife, here in Canary Islands. This is not an exhaustive list of the centers that are doing research in radio astronomy and development. Here you see the 2 radio observatories, plus the Quixote experiment in Canary Islands, and the Deep Space Network antennas that we also use to do radio astronomy in Madrid, with 2 very important outreach projects that we do with the smaller antennas. With a 34-meter antenna, we have the partner project, that is an educational project, and in ESA, we also have a collaboration in the CESAR project, and we also use one of their antennas to teach radio astronomy to students. And here also, in Yebes, we have a processing center, a VLBI correlator for a geodetic Portuguese and Spanish network, and of course the Barcelona Supercomputing Center, Mare Nostrum 5, just opened, together with the scale in Castilla y León. And very important, IAA is establishing the first SKA Science Regional Center prototype for the Spanish community. And these are all the IGOs that we participate, like SKAO, ESA, ISO, ERICS, like JIVE, and other international collaborations, for example, with the EHT collaboration, or NARIT in Thailand. So, some numbers about the Spain in the astronomy and space science. We are the 4th country in this GDP rank. Our contribution to ISO is, it was last year, 7.81%. Our contribution to ESA is 8.3 for these last 4 years, including the 8% that is mandatory because we are members. We dedicate from our national funds, we've dedicated 2021 national funds about 3,000 million euros to research and development in fundamental research. And this means about 5–6% of the dedicated to astronomy and space science. And we are, in the past years, we were the 8th country in this rank, the SIMAGO rank, for astronomy, astrophysics, and planetary science. And last year, we became the 7th. So our participation in ISO, we've been members of ISO for more than 15 years. We participate in all the boards, all the committees. We have Spanish colleagues working in Germany, in Chile, and we are very proud to have the Director General, Professor Barcons, that is Spanish. So we are contributing about 16 million euros per year. And the development of an exploitation of ALMA had a huge impact on Spanish R&D, and you'll see in a second. The industrial technological return coefficient has been during these past 10 years perfect, but in 2022 it was 1.98. So, and the total amount of papers by Spanish colleagues amount to 23.4% of total ISO papers. Collaboration in ESA. So we are contributing in these last 4 years with 1,200 million euros. We have the European Space Astronomy Center in Madrid, very important center, and we've been involved in the space instrumentation. For instance, in Integral, we led for first time an instrument. In Gaia, we were responsible for the critical system, and we collaborated in the data simulation and processing. For Solar Orbiter, we led 3 subsystems and 2 instruments, and for CHEOPS, it was the first time that Spain was leading a whole platform. And this is the educational project that I was telling you before. So, Spain in the context of the European research, I wanted to give you these numbers. So, since 2007, about 16,000 projects were funded by the European Commission. 1,000 of them were Spanish. And here in the panels for System and Telecommunication, Communications Engineering, and Universe Science, we are in the position 8th for number of projects, and in the position 6th for the amount of money that has been granted. Out of these projects, 13 were radio astronomy research projects, and one very important, one of them was is a synergy project that is led by Pepe Cernicharo. Okay, and now I want to review with you the main radio astronomy R&D centers in Spain. So I wanted to start with as we are in Canary Islands, I wanted to start with the Instituto de Astrofísica de Canarias, that they manage 2 observatories, the Roque de los Muchachos Observatory and the Teide Observatory. In Roque de los Muchachos, they are building the new European Solar Telescope, and CTA North very important for the Spanish astrophysics. And in El Teide Observatory, they have the Quixote experiment. That Quixote is trying to study the cosmic microwave background. And till now, they've done the most detailed study of the polarization of the emission, microwave emission from our galaxy. Spain has been collaborating in the Planck mission with all the scientific exploitation. We collaborated in the low-frequency instrument, but also from IAC, it was led as a group of 50 researchers that were studying the distortion of cluster of galaxies on the CMB. And we are collaborating in the development of this 40-meter radio telescope in Brazil, the Bingo telescope, that is going to try to detect the baryonic acoustic oscillations from the early universe. So they have all these laboratories, but very important, their technology division that provides technology development and production support for research and technology projects. And they have this hub, the EAC Tech Hub, that is a space for transferring technology from the public institutions to the industry, to the Spanish industry. Now I wanted to tell you about the Astrophysical Institute in Andalusia. They are also managing two observatories, the Sierra Nevada Observatory and the Calar Alto Observatory in Almería. And they are doing radio astronomy research, fundamental research, in two groups, the radio astronomy and galactic structure group, that they are mainly studying AGNs, relativistic jets, star planet formation, and also studying the latest stages of stellar evolution. The other group, the extragalactic astronomy group, is studying the nuclear activity in galaxies and how the effects of the environment affect how the galaxies evolve. Very important, EIA has been instrumental in the possibility of Spain joining the SKJ. So in the preparatory phase, IAA was leading the effort to publish the Spanish SKJ White Book with 29 chapters of all the science that could be done by Spanish researchers using the SKJ. In 2018, Spain joined the SKJ organization at that time, and this organization evolved into an IGO in 2020, and it was in 2023 that Spain joined the IGO, the SKJ IGO, adding 41.4 million euros to this effort. And very important, in IAA, they are developing the Spanish prototype of the SKJ Science Regional Center to prepare the Spanish community, to provide the tools and prepare the Spanish community for this challenge of exploiting the SKJ science. And also they are helping the Spanish community to participate in the SKJ data challenges. Okay, and these are the facilities that they have, the laboratories. Their technology capabilities are mainly related with the development of rocket, balloon, and spaceborne astronomical payload, instrumentation, and space missions. They are experts on cryogenic vacuum technologies that they've learned through ALMA, PAN1, and Cármenes, that is an instrument in Calar Alto Observatory. And they have optical design, they've designed optical for astronomical instrumentation, invisible and infrared, and they also do software development with BOE standards, big data solutions, and also the FAIR principles. Okay, now I wanted to tell you something about IRAM, the 30-meter radio telescope in Pico Veleta in Granada. So IRAM was the first European millimeter wave radio astronomy center in Europe. is a French-German-Spanish institute founded in 79, and Spain joined as a full member in the 1990. It operates two observatories, NOEMA and Pico Veleta in Granada. They are Spanish ICTS, and they went through a very major upgrade during this last year. They are finishing now, and they are building new instrumentation like this kit-based bolometer, the Shera, multi-beam, and with an enormous 32 gigahertz instantaneous bandwidth per pixel. And these are some highlights of the science that they support. Just wanted to mention mainly their contribution to the EHT, the Event Horizon Telescope observations, that without Pico Veleta and the UV coverage that they provide, we cannot see the effect of the shadow of the supermassive black hole in M87. And all these other signs, for the interest of time, I'm not going to tell you. And now, I wanted to tell you a few lines about the National Geographic Institute, that is the institute I work for, that manages two observatories, the National Astronomical Observatory, that is located in Madrid, with the astronomers, with the radio astronomers, and the Yebes Observatory, that is also an ICTS with a 40-meter radio telescope in Guadalajara, with also the Technological Development Center. So the science that we do in my institute, we are studying evolved stars, our galaxy and interstellar medium molecules. With a 40-meter radio telescope in these last years, we've been able to detect more than 70 new molecules in space. We also contribute to studies of the fueling and feedback in galaxies that are so famous now, and simulations for preparing the SKA to collaborate in the BLBI global networks. In Yebes, we have also all these facilities, two radio telescopes, two optical telescopes, a new just installed satellite laser engine for geodesy, the gravimeter pavilion with a superconducting gravimeter, an anechoic chamber that can go up to 140 gigahertz, the only one in Spain that can go so high in frequency. We have geodesic pillars network to measure all our distances, and an outreach pavilion. Laboratories, including the very famous low noise amplifiers laboratory, and our technology capabilities we are able to develop complete receivers for radio astronomy and for geodesy. And we have international reputation in high quality, low noise cryogenic amplifiers development. For instance, the one we provided for the Herschel ESA mission. We are participating in several upgrades right now, like the ALMA 2030, BLBA now, etc. And also, for the interest of time, I have here highlighted all this science that is done by other institutions, like the Valencia University with their astronomical observatory, but I'm not going to tell you about this. The Barcelona University with the Institute of Space Science, and the Astrobiology Center in Madrid. And the last one, but not least, the Fundamental Physics Institute, and this one is the one that hosts the PI of this synergy grant that we got from the European Commission that is called Nanocosmos, that his PI is Pepe Cernichar. Okay, and now to finish, I wanted to finish this part of the present. I wanted to tell you a bit of how this has developed in the Spanish industry. So we've received contracts during these last 15 years for 1,400 million euros. And our membership on ESO has made that we have developed so much our industry that we have acquired these capabilities to contribute to R&D in radio astronomy. So, examples. For RF technologies, we have TTI North that has developed the cryogenic LNAs for ALMA, or DAS Photonics, that has made local oscillator test module for ALMA. In the topic of manufacturing large structures and precision machining, Asturfeito provided the antenna mounts for ALMA, and CENER the robotic arm for ALMA calibration. And in infrastructure and energy, TSK built a multi-fuel power plant with a 10 million euros contract. Some other topics, vacuum and cryogenics. So our companies have been able to develop end-to-end cryogenic for the Carmen instrument in Yebes Observatory. And we have these other competences like distributed control architectures, distributed data and imaging processing, RF electronics, and synchronization. Okay, and now to finish, I wanted to tell you some lines about the future, how this is evolving in the future. So we are participating in technological innovation for the next generation of instruments, of radio telescopes, and we are participating in this European project, the radio blocks, that is building these common blocks for the radio astronomy infrastructures. And Spain is contributing to the part of novel detectors and components in the low noise amplifiers, the IF low noise amplifiers, with the goal of achieving 30 gigahertz bandwidth amplifiers. And we are also working on balance amplifiers. And we are contributing to the data processing toolkit for advanced radio astronomy that we would like to develop for all these infrastructures. Mainly for the simulations to optimizing the calibration and parameter extraction and novel dynamic imaging techniques like the ones that are used for the Event Horizon Telescope. We are also contributing to the VLBI of the future in millimeter wavelengths using frequency phase transfer technique. With our 40-meter radio telescope, we are able to perform this technique. And with this, we are going to increase the sensibility and the dynamic range of the images in an order of magnitude. At lower frequencies, we will be able to achieve effective angular resolution similar to EHD. And very important, the goal of high precision relative astrometry up to 1 microsecond. And also, in Spain, we are committed to this development of KIDS technology, mature this development for bolometers. We are helping building the SKA as members that we are. In the design consortia, we participated 12 institutes and 12 companies, and there are pre-allocated contracts for Spain, Band 5 ortho mode and feed horns, Band 1 feed control is package, SKA mid and SKA low UTC distribution that has been already granted, and the SKA mid dish sub reflectors. And 2 operations contracts have been already granted. There is the rebranding of the SKA brand and a reverberation chamber in Australia. So with this and all the preparatory work that has been done with the white book, the Spanish community is ready to exploit the SKA science and participate in the key science projects. In cosmology, in Tenerife Observatory, they are developing what they call the CMB lab. That is a hub of experiments to study the cosmic microwave background. We are participating in the Japanese mission Lightbear to study the imprint of inflation in the CMB. And also, as I told you before, we are participating in the development of this 40-meter radio telescope in Brazil that tries to detect these bionic acoustic oscillations from the early universe. I just wanted to mention, this is not radio astronomy, but I think it's important because it's using VLBI and the radio astronomy techniques, so going beyond radio for sub-millimeter and terahertz regimes. We've participated in this concept, the TESA concepts, terahertz exploration and zooming in for astrophysics. and we signed this white paper for the ESA's Voyage 2050 for a medium mission. We would like to collaborate in the next generation EHT with improving the capabilities of the Yebes telescope at 1 millimeter, and maybe with another antenna in Canary Islands. And also we will participate in this proposal, the Event Horizon Explorer, that it will be a space component for the EHT. And also we are participating in these proposals, these 3 far infrared proposals for missions in far infrared. First, Prima Saltus, for this announcement of opportunity, recent announcement of opportunity for an APEX mission, for a NASA APEX mission. Okay, so this was the journey I wanted to take you today through the past, present, and promising future of all the radio astronomy activities. Thank you very much.
Thank you, Cristina, for your very nice overview of the impressive amount of activities in radio astronomy in Spain. Are there any questions from the room? Cristina. Please stand up because I'm a little bit blinded by the lights. I have a question regarding the Event Horizon telescope. You mentioned a couple of developments like the improvements through the frequency phase and the addition in space to further enhance the resolution. But another challenge for the EHT is the very poor spatial coverage, which is also a challenge for image reconstruction. Are there any plans to improve the baseline coverage, the free space filling?
Okay, so of course, as I mentioned, we want to add more telescopes, more addition of new telescopes to the network. So in Yebes, we are studying if we are able to improve the surface of the primary mirror and develop a 1 millimeter receiver to be able to collaborate in these observations. And from IAA, there are efforts to install another radio telescope in Canary Islands to determine where. So, and well, apart from these efforts from Spain, there are many other efforts like the Namibian telescope, etc. So, yeah, so with the aim to improve the UV coverage of these observations.
Out of curiosity, where in the Canary Islands, what's the prospective sites that you're thinking about?
Where to? I think it was in La Palma. They are thinking of installing it in La Palma.
Okay, thank you. Any other questions? Yes?
Yes.
Yeah, thank you very much for this huge presentation of all. For what I've seen, it's very high frequency, at least from my point of view. Is there any hope to see some development or even at lower frequency, which means 10 megahertz or something like that in the future? I've seen SK low, but that's all. There's no need to go lower.
That's very good. That's very good question, and it's a very good topic. So the Spanish community in Spain is starting to realize the importance of the low frequencies. So a group from Valencia has just studied ultra cool dwarf, the magnetic field from this star, and that would be wonderfully done with low frequencies. The problem here that I didn't mention, I think, for Spain, is the RFI environment. Okay, so we are fighting in the Yebes Observatory. Just this last weekend, we had a demonstration because they want to install this solar station very close to the observatory, and that generates RFI. And the status of RFI at low frequencies, it doesn't look good. So, so there's some interest from the Spanish community, but maybe not enough to push the Spanish funding agencies to install, for instance, a LOFAR2 station. That would be so nice to have in Spain. With some students, as a side, with some students from Madrid University, they are going to develop a CubeSat and launch it to study the sun at low frequencies with dipoles, mimicking the sunrise mission, the NASA mission, the JPL NASA mission. So, well, but yeah, as you said, sadly, there's no much Spanish contribution to low frequencies.
Okay, any final questions?
Yes. Up there. Yeah, could you please pass the micro? Just a second.
Thank you very much, Cristina. This is James. It's good to see all the things you've done in Spain over the last 2, 3, 4 decades, and to see old friends and when they were younger in the pictures. But I would like to understand a few more things about specifics, like what is the current status of the SKA SRC in Granada? And I didn't see much of educational program, especially to train younger people. How are you able to generate a pipeline of people who get into the different astronomy programs? You showed much of the projects, but I would like to hear a bit more about the people and how you created pipelines. And also one last simple question is, do you have plans to participate in the NGVLA project? Is there any Spanish footprint on the NGVLA? Thank you.
Okay. Well, the Spanish SRC prototype is quite well advanced. I would say one of the ones that are really starting providing results. They are analyzing all the pathfinders and precursors data, and we are going to have a talk about it during this week. I don't remember right now what day, but I'll tell you later, and I'm sure you are going to be very interested about it. About the NGVLA efforts, we will be also pleased to have funds, for instance, to install an 18-meter dish in Yebes or in any other location, a better location. So yeah, and to contribute to that effort as well. Thank you.
Okay, thank you. So now it's time for the coffee break, and I don't want to hold you for that. On the other hand, if there are further questions to Cristina, I'm sure she will be around here for the next few days, so please don't hesitate to contact her in the hallways and ask your questions to Cristina. So thank you all let's thank Cristina again and enjoy the coffee break.